Mr. Sheda, we are pleased to inform you that we have received the data from the lab tests for the brush heads and have thoroughly analyzed it. The following is the methodology used in the analysis.
First, we gathered the failure load data from the testing of 16 brushes. We discarded one of the tests because the brush didn't break in the machine properly. We then plotted these 15 data points on a scatter plot to confirm that the data was IID, and then on a probability plot and confirmed it was free of outliers. Then we calculated the basic sample statistics, so the mean, median, and standard deviation, and used these to estimate the 10th percentile of the failure strength distribution using two different methods. For the first method, we assumed the data was a normal distribution and used the formula mean minus 1.28 times the standard deviation. For the second method, we used the formula 100 times I minus 0.5 over n equal to 10, and equals 15. We calculated I to be 2, which means the second smallest number in the set was our estimate for the 10th percentile.
Using the mean and standard deviation we found from our 15 samples, we made a normal distribution plot. From that, using Minitab, we found the value of the 10th percentile to be 133.0. Because the estimate we found from the first method, E1, was 133.1, we chose to use that one. Using that same mean and standard deviation, we then simulated 10,000 sets of 15 tests using Minitab. Using the same methods described earlier, we then calculated E1 and E2 for each of the 10,000 sets and compared them using a histogram. From that, we found that the mean for E1 was closer to the sample estimate we calculated earlier, and the standard deviation was smaller. We also found that the bias for E1 was closer to 0 than that of E2. Based on the interval we calculated using the estimate plus or minus 2 times the standard deviation, we found that 110 was contained within the interval with 95% confidence.
Ms. Little, having successfully completed the analysis of the data sent to us by Tyler Sheda, our team feels confident in making a recommendation moving forward regarding the brush head problem. We feel, based on the analysis, that there are two different directions we could possibly take. The first option is to continue the testing. This would require more time and more resources, but it does give the opportunity for us to more confidently be able to state whether or not the brush heads are falling within the required specification. The second option is to continue the manufacturing of the brush heads under the current process. Our team feels that this is the better of the two options. We feel this way due to the fact that the analysis of the data revealed that the lower bound of the interval at which the brush heads fail is 104 pounds. We feel that due to the fact that 104 pounds is only slightly less than the target specification of 110 pounds, that it is not worth the extra time and resources to continue the testing. If the number were further off, or if we were dealing with something more life and death than hairbrushes, the extra testing would most definitely be required. But due to the fact that it is very close to the target specification, and that it's not that big of a deal whether or not the brush fails at 104 pounds or 110 pounds, we feel that the best choice is to continue moving forward with the process as is. This will save both time and money, and we feel that this is the best option for the team as we move forward with the brush head problem. Thank you.